Alright, in this video it is time to put together the node editing code. It's at this point that we're ready to make the operation of node editing something that we can do interactively inside of the scene editor. Now, before we jump into the scene editor, let's clean up those demo actors we had created back in the base scene. We had created some actors just to show that selection was working, and at this point we are really ready for those to go away, because we're about to have the ability to create nodes from inside of the editor itself, so we don't need additional actors lying around on the screen. So let's get this file saved out and turn our attention over to the scene editor. Now, inside of the scene editor, there are a few different topics we're going to cover. We're going to cover the creation of nodes, the deletion of nodes, connecting nodes that already exist, and breaking connections between nodes. So let's begin with the topic of node creation. We want to be able to create nodes by shift-clicking anywhere in the scene. If we hold the shift key and click the mouse, we'd like a new node to pop into existence at that location where our mouse cursor is currently located. So let's move up here to our mouse input code, actually moving down to the mouse down section. Let's jump in here before we handle selection, because again, mouse down is going to become one of the most heavily loaded methods here, since it has a lot of different responsibilities. In addition to the selection code we've already written, we are also going to have node creation code. So let's put some of this code together. Let's do a check, and we'll say if the shift button is currently pressed. So if keyboard input dot is shift down, then we know we're holding the shift key. And also, to make sure that the code doesn't get confused as far as what's happening, we're also going to return from the mouse down method in the case that the shift key was pressed, because shift is going to indicate that we need to be creating nodes. We don't want any of this code to interfere with our selection code. So in the case that we get a shift down, we simply shortcut and avoid the rest of this code. Now, depending on what your preferences for flow control are, you may instead choose to represent this as an else statement and then bracket everything here into the else. So shift down, do creation else, do selection. But I mean, really, that just comes down to a matter of preference. Here, because of limited screen space, I opted to go with a simple return to avoid executing the selection code. Alright, back to node creation. If the shift button is down and the mouse button is clicked, we need to create a new node. We'll do that by using a local variable of node to hold the reference, and we'll turn around and initialize this reference to a new instance of a node. Now, with our new node instance, the first thing we'll do is we will position it. So we'll say node.position is equal to the position passed in from the mouse down parameter. So node.position equals position. In addition to this, we're also going to make sure that this node gets selected. So if we already had selections in place, let's make sure we clear those out and make the brand new node be the only selected actor. So first, we'll take our actor selection list and we will clear it, and we will select the node. So node is of course an actor. We can invoke the select method, so that will take care of selecting the node. So with this in place, let's run the game and try it out. Here is our blank empty scene. If we hold the shift key and click the mouse, we get a brand new node. As a matter of fact, the node is drawing with the green color to indicate that it is indeed selected. If we hold shift and click somewhere else in the scene, we get a new node, and the previous node gets selected. So now I can happily go through and click out as many nodes as we'd like. And because nodes are actors and we have actor editing ability, we can hit W and change over to move mode and grab any of these nodes and move them all around the scene. We can even select multiple nodes and move them around as groups. Now, in order to make the connecting of nodes go a little bit faster, we'll do a setup here where if a node is selected when creating a new node, we'll make a scenario where these two nodes would get automatically connected. So if we wanted a node connected to nothing, we could deselect everything, make a new node, but we do want to be able to connect nodes quickly as we're creating them. To do this, what we'll do is as soon as we create the node, we'll do a check, and we'll see if there are any selected nodes. So let's actually store the last node that was created itself as a local variable. So we'll make a variable called last node. And we'll set that to be equal to actor dot last selected casted as a node. Now, of course, the as casting operator here is going to return null if last selected was something other than a node. So we need to do a check and make sure that we really did see a node as the last thing that was selected. So doing this check here, we can say if last node is not equal to null, then we do have a node as the currently selected last actor. So we have two nodes, and we can make a connection between them. Now here we need to make two connections, so we'll leverage the bidirectional connect method held within node. That means we can take node and say bidirectional connect, connecting to last node. And that should be all we need to do. So we check our selection. If that is a node, and it is indeed not null, make a connection between the new node and the last selected node. Then we will clear the selection and reselect only the new node, so we have the appropriate node selected to continue the node chain. So to test this out, we'll hold Shift and click out the first node. We can see that that node is selected, so we'll hold Shift and click a second node, and we see we get this connection between the two nodes, and the new node is selected. So now we're free to move around and draw out a path using these nodes. Now if we hit W and move over into move mode, we can grab any of these nodes, move them around, and we see the connection lines update to show how our nodes are connected. Also, if we deselect all of the nodes and hold Shift, we can make a new node chain not connected to the previous one. So now we have a very fast way of creating node paths. The next thing we need to address is a way to go about deleting nodes. So here in code, the way we're going to handle deletions is whenever the keyboard delete key is pressed, we will delete any of the selected actors. So in order to implement this, we'll actually move up back to the keyboard key release section, and we will throw in an additional else if statement. So after we check the W key, we will throw in an else if, checking to see if key is equal to keys.delete. If we are pressing the delete key, then we will loop through all of the currently selected actors and delete them. Another thing to note here is that deletion is going to work across all actors. We simply didn't implement it earlier since we wanted to show everything as relating to nodes. But it should be noted here that delete will delete any editable actor. So to perform the deletion, we'll simply loop through the selection list and call delete on anything that is selected. So we'll put together a for each loop, and we will say for each actor in actor.selection. We'll take each of these actors and call their delete method. Since this is a single statement, I'm going to pull the braces out of the for each loop, and this code is all we need to use in order to accomplish the actual deletion. But we need to keep one thing in mind here. Actor.delete is pulling the actor out of the actors list. It's not doing anything to the selection list. So if we did only this, we would leave selection in an inconsistent state where we have actors existing in selection that don't actually exist in the scene. So right after we delete any of the selected actors, we need to make sure that the selection itself gets cleared. So we'll simply call actor.selection.clear. Of course, since the deletion was based off the selection in the first place, we'll make sure the selection gets cleared back out, and now we don't have any references to actors that don't exist. So let's run and try this out. Let's hold Shift and make a series of nodes. Then let's grab one of these nodes and press delete. You can see that the node did in fact get deleted. And of course we have the additional code in nodes override of delete that handles cleaning up these connections. So we can show that by dropping in a few nodes, and then, let's see, drop in an additional one. Actually, let me see, drop. What I'm putting together here is an old test I was using when developing. Connecting a series, a new node that's connected, delete that, and then move on, and making sure that there was no ghost connections leading to this actor. Also making sure that the actor list gets cleared. But now we do have the ability to delete any actors we would wish. So that is relatively simple. And now we can move on. The next thing we need to address is connections between existing nodes. For example, if we had drawn out, let's say we wanted to draw multiple connections where we had a series of nodes, another series of nodes, and then we wanted to add some vertical connections between these horizontal paths. We would need some way of selecting nodes and building connections between them. So what we'll do is we'll assemble some code that will look through the selected nodes and make connections between them. We're also going to build this in a way that will handle multiple connections in one run. For example, if we wanted to build connections between all three of these nodes, we'll set up a scenario where the code can loop through all three nodes and build connections between them. Now, in order to accomplish the connections, we're going to use the keyboard key C. So if the C key is pressed and we have enough actors selected, then we will begin the connection operation. So right here inside of the keyboard input key release handler, we'll add a new else if statement, and we'll say if key is equal to keys.c, and we have enough actors. So we'll say and actor.selection.count is greater than or equal to 2. Now we'll begin a for loop that will walk through all of the selected actors. Then we'll check and see if those actors are nodes. If they are nodes, we'll make connections between them. So we'll put together a for loop. I'll hit tab twice to bring up the template. We'll leave the index variable as I, and we will loop over the selected actors. So that is actor.selection.count. Now, one change I will make to the for loop is we don't want to start at the first actor. We want to actually start at the second actor. So we'll loop from 1 to the last actor. That way we will be able to always look at a last actor if we loop in this manner. Since we're beginning at the second actor, we know we can always look backwards for the other actor. So let's make some node references so that we can begin connecting the nodes. Let's make a node local variable called node A and set that to be equal to node dot, actually looking at this, this should be actor dot selection sub I minus 1. Then we will cast this as node. So again, when we're using the selection list, that's a selection of actors. We need to try to cast those to nodes so that we can use the connection methods. Also, node A, we're looking at this as the first node. You can see that we're taking the current index variable minus 1. That's why we're starting 1 to the list, to make sure that the first one is indeed a valid element in the selection list. Now we need the second node, so we'll make a node variable called node B that will be equal to actor.selection sub I. Again, casted as a node. So this is what I was talking about with the last node always being selectable. Now we need to do a check. Since we casted these actors as node, we are not yet guaranteed that they are in fact nodes. So let's do a check to make sure that both node A is not equal to null and node B is not equal to null. If this case is true, then we know that both of those nodes were actually node objects, so we can perform a connection. Let's look at node A and perform a bidirectional connect to node B. And with that, that should be all we need to do in order to establish a connection. So let's try it out. Let's begin with something simple. I'll hold shift, make a node. I'll click out to deselect that node, and hold shift to make a second node. Now I'll hold control and select both of these nodes, then hit the C key. And we can see that a connection appears between these nodes. So as we move them around, that forms our connection. Now for a more complex example, let's draw out 3 separate paths, all horizontal, each containing 3 nodes, and let's do what we were attempting to do before. We want to establish vertical connections between these, but in a relatively quick manner. So watching the order that we select, we'll select top, middle, bottom, hit C, and we get connections between all of them. So in this way, you can go through and much more quickly create connections between multiple nodes. Now, of course, the order itself is important. So if we were to draw out an example with additional nodes and connect, let's say we connect this node, then this node, then this node, then this node, and hit C, we actually jump out and then between these. We already have a connection between these two, so we don't duplicate that connection. But just pointing out that because we're looping through the selection, and the selection is built actor by actor, it will maintain the order that things were selected in as we're building connections. Alright, now we have one last topic to take care of in our node editing. Excuse me. This last topic is disconnecting nodes. If we had made connections and wanted to remove them, we need a way to delete the connections between existing nodes. We'll use the X key to accomplish this. We'll also allow disconnections between more than two nodes in the same way that we allowed connections. As a matter of fact, we'll use the same system of looping through the selection list. So we'll implement disconnecting by copying the code starting at the C key, currently used for connections, and paste that in to duplicate it. We'll change the key that we're looking for to the X key, and again make sure that we have at least two nodes selected. We'll loop through the selection, starting just past the first element, establishing node A and B out of the selection. Then we'll check the nodes, make sure they're not null, and if they are not null, then we'll perform a bidirectional disconnect rather than a connect. So now if we run and create a series of nodes, now let's say we want to establish a new chain and forgot that node was selected, and we didn't want this connection between these two nodes, we can select both of these, hit X, and break the connection between them. Also, if we had many selected nodes and wanted to break the connections between all of them, we could select as many nodes as we'd like, hit X, and delete all of the connections. So with this now, we have implemented node creation, deletion, and connections and disconnections between nodes. So with that, that is going to wrap up this video.